Hello everyone. In today's lecture we are going to learn about numerical operations on NumPy. In the previous video you have seen the introduction about NumPy, which included how to create an array in NumPy and some different functions in NumPy, including the data types in NumPy. Now let's see how to work with the mathematical operations that is being involved in NumPy. Now initially, as we already know, to start using NumPy library, we need to first import it. So we import NumPy as NP. Then let's start with some basic scalar operations. Here we are having a NumPy array 1, 2, 3, 4. So here I am doing a plus 1. I'm adding a value, I'm adding an element. So this element is not only adding to one particular element in the array A, instead this 1 will get added in each element of the array. So if I'll run this, then a plus 1 I'll get as 2, 3, 4, 5. We can see that each element is being added by 1. Now let's do matrix multiplications. Here I am having an array with a matrix, or I should say with diagonal entities as 1, 2, 3 and 4. So I am using np.diag. So now to get the multiplication, I can simply do c into c. So as we already know that a diagonal matrix multiplication by itself will give me 1, 4, 9, 6, 16 in the diagonal elements. I can do this in another way also by c dot c. So c into c is similar as the dot product, basically c dot c. Now suppose we have two NumPy array and I want to compare between them. So here I am having A as 1, 2, 3 and 4 and B as 1, 3, 2 and 4. Now these two these two arrays have different elements and I want to compare each element correspondingly. So what I can do, that I can use A equal B, and this will give me a NumPy array which will have the Boolean values basically. So here it is comparing each element correspondingly and giving me a Boolean value. So here we can see that 1 and 1 they are equal, so we are getting true. Then 2 is not equal to 3, false. 3 not 2 and false. Then 4 and 4 they are same, so true. Similarly, we can use different kind of operators here, like A greater than B. So we are getting this false, false, here 3 greater than 2, so true. Now there is another way in which we can compare the two NumPy arrays completely. That is np dot array underscore equal a comma b. So this will give me the output false here. Why? Because we can see that some elements are not equal. So it will give me true only when all the elements correspondingly are equal to one another in A and B. Okay. Now we can use some logical operations here also while comparing. So here I am initializing two NumPy arrays with the data type bool. So you can observe I am giving the value 1, 1, 0, 0. So here 1 stands for true, 0 stands for false. So suppose if I'll print A, then I'll get true, true, false, false. That means whatever values that are 1, corresponding to that I'm getting true, true, and then 0 for false. So suppose I want to compare between them with an operator AND. So we already know that an AND operator, what it gives, 1, 1 gives 1, 1, 0 gives 0, 0, 1 gives 0, 0, 0 gives 0. So in this I want to use an logical operator AND. So here I'm using a function logical underscore AND. So this is a function inside NumPy library, as we had this function array underscore equal, which is used for comparing the two arrays. This is also a function inside NumPy library. Similarly, we are having this function logical underscore AND. So as we already know what this AND operator do, so we are able to see that 1, 1 gives true, 1, 0 gives false, 0, 1 gives false, 0, 0 gives false, that is 0. Similarly, instead of AND operator, we can use OR operator also. In OR, we already know that 1, 1 is 1, 1, 0, 1, 0, 1, 1, and then 0, 0 is 0. So for 0 it is false and 1 it is true. Now, there are some useful functions in that in mathematics that we use in our everyday life, like sine function, log function, and all. So let's see how to get them in use using NumPy library. So here a is equal to np dot a range. Oh, so I'm getting a as 0, 1, 2, 3. Now, suppose I want to get the sign value of each element that is present in array A. So here I'm getting sign of 0, 0, sign of 1 this, sign of 2, and sign of 3. So instead of sign, if I want to get log, then I can see that log of 0 is minus infinity, then log of 1 is 0, log of 2 is this, and similarly we can use exponent function. Yeah, so e's power 0 is 1, e's power 2, e's power 1 is this. Yeah. Now let's see how to compute a sum of an array using the functions, inbuilt functions in the NumPy. So here a is equal to np dot array, that is 2, 3, and 1. So we are having an array 2, 3, 1, and I want to compute the sum here. So what I can do is that np dot sum x. So if I print this, oh, it should not be x, it should be a. Yeah. So here I'm getting the value 6. 2 plus 3 plus 1, that is 6. Now instead of like here in this case we have just a one dimensional array. Suppose I have a matrix. So here I am having a matrix 1, 1, 2, 2. There are 2 rows. And in that I want to compute the sum in a particular way. I mean that I want to have the sum along the column or along the rows. So if I do the sum here along the column, then what should I do? I can do x dot sum, and then I can give the direction of calculating sum. So axis is equal to 0 here I am giving. This is the argument. This is very important. I am giving axis is equal to 0. This means that it will do the sum vertically. So suppose I am running this. Yeah. So here this is the output of this command, x dot sum axis is equal to 0. So vertically when it is doing, so it is doing 1 plus 2, that is 3, 1 plus 2, that is 3. So it is computing sum vertically of each column basically. So if I do sum along axis 1, then this is giving me 2, 4. Axis 1. Axis 1 means it is computing the sum horizontally along the row. So 1 plus 1, 2, 2 plus 2, 4. Okay. Now suppose in an array I want to find what is the minimum and maximum element that is present, or the position where they are present, these maximum and minimum elements. So I can use a min-max function. So here x dot we are having a, so a dot min and then parenthesis. So it will give me the minimum value of the array a. So that is 1. So instead of min, I can do a dot max also, 45. Now suppose I want to get the location of that particular maximum value. So what I can do, that I can give arg of min to get the index of minimum value. So here the index of minimum value, that is 1, is 0. Similarly, to get the index of maximum value, I can use arg a dot arg max. This is the function that we are using, and I got 2. So this is my maximum value 45, and the index is 0, 1, 2. So this index value is 2. So I'm getting 2. Now there are certain other logical operations that are quite useful. Here suppose we have a this matrix which is 3 cross 3 matrix and contains all the elements as 0. Now I want to know whether all the elements are 0 or not. If any of the element in that 3 cross 3 matrix is non-zero, then it should give me false. Now here what I am doing, np dot all. So this is a function in NumPy which basically satisfy the condition that is being given inside the parenthesis. So this is the condition that x equals 0. So it is giving a condition that each element of the x matrix should be 0. So when I run this, I can see that the value is true. It is claiming that each element in that x matrix is 0. So this is all. So all is basically an operator like AND, and there is another function that is any, which is kind of an OR operator, which tells me that if there is any, then you can go ahead. So I can just explain this. Yeah, so if I am giving a not equal to x not equal to 0, so if any of the x is not equal to 0, then return true. But here, because all the x are 0, so this will return false. So any means if any of the element is satisfying this, then just return true. But since here none of the element is satisfying this, none of the element in x is equal to 0, so it is returning a false. Now let's have a more insight about this any or all function. Now I am having two different numpy array here, 1 2 3 and 2 3 4. So here I am printing a less than equal to b. So this will give me an array with the boolean value. So here true true true. This means that a is always less than b. In all the elements, if we compare, 1 is less than 2, 2 is less than 3, 3 is less than 4. So the value here is true true true, because this is being satisfied in all the elements correspondingly. Now if I want to know whether this condition is completely holding, I mean that I am getting this output. So if all the element in this list is true, then only this function will give me true. So this all is signifying that it should be wholly satisfied. This condition, there should not be any exception in satisfying this condition. That means that a is less than equal to b should be true for each and every value, for all the values inside the array a and b. So then it is giving true. Suppose I am making it as 3. So here, this is equal, so I am making it as 4. So yeah, so here we are seeing that this is true, but here the condition became false because this is greater than 3, and here it is true. Now because we are having one false here, not all the values are holding true, so in this function we are getting the output as false. Okay, now there is another there are many different other functions that is very helpful while in the statistical part. Suppose we are having an array and we are having a set of data maybe, in which we have to find mean, median, standard deviation. That is a very common term in statistics. So let's see how that thing works. We are having a numpy array here, that is 2 1 3 0, and I want to calculate, suppose, mean here of x. So if I'll run this, so this is what exactly is the function mean that is inbuilt here, which we are just using to get the mean of numpy array x. So if I'll run this, I'll get the print value, that is 1.5. It means that 2 plus 1 3 plus 3 6, and total number of elements 4, so 6 divided by 4, that is 1.5. Similarly, if I want to compute the median, then I use numpy.median. This is important, and then in that I am giving the array. So np.median x is giving me 1.5. So I hope that all of you know how to calculate median. We first need to rearrange the array into ascending order. So here it will be 0 1 2 3, and then middle values we want to calculate. So here the middle values will be 1 and 2. So 1 plus 2 divided by 2, that is 3 divided by 2, that is 1.5. Okay. Similarly, if I want to compute standard deviation, then I can simply use x.std. Yeah. So here this is my standard deviation. Now this was the case when we are having a single dimensional array. Suppose we have a multi-dimensional array, 1 2 3 4 5 6. Now I want to compute the row wise median. Now to compute the row wise median, what I'll do, I have to provide the axis. So we already know when we want to compute horizontally, then we have to justify when we have to give the axis number, whether it is 0 or 1. So we are giving it 1. 1 means compute horizontally. So it will compute the value horizontally here. So this is, let's first print y so that we can visualize better. And then we have np dot median in y with the axis 1. So it will compute row y. Yeah. So 1, 2, 3. So the median of this row will be 2 and the median of this row, second row, will be 5. So 2 comma 5 is the output. Okay. Now having this done statistics, let's observe what if we have a two-dimensional array and we want to convert it into a single one-dimensional array. So there is a concept called flattening. So in this flattening, what exactly is happening, that suppose let's print this a. So this is like this, two-dimensional array 1, 2, 3, 4, 5, 6. So the shape of this is 2 cross 3. Now I want to flatten it. So there is a function inside this, that is revel. Now when we do revel, then we get a single dimensional array that is being flattened. So 1, 2, 3 and then 4, 5, 6 is being added here. Now similarly, to calculate the transpose of any matrix, we use dot capital T. So we have a matrix A that is 2 cross 3 and I want to calculate the transpose. I want to get the transpose value of it. So we already know what the transpose is. It is just like the 45-degree mirror image of the matrix. So 1, 2, 3, 4, 5, 6. So we are having 1, 4, 2, 5, 3, 6. Okay. So this is the transpose of A. Now suppose I want to flatten this. I want to flatten this matrix, that is the transpose of it. So I can do A dot transpose dot revel, and simply that. So see, this is giving me 1, 4, 2, 5, 3, 6. How? 1, 4, this is 1, 4. Then next 2, 5, 2, 5, 3, 6, 3, 6. So each row is getting appended. Okay. Now what if I want to reshape my matrix? I want to reshape my array. Here I am printing A, like I am using the above A only. So let's see. Yeah, so this is my A. Now I have flattened A and gave it a name B. Now this is B, that is a flattened A. Suppose I want to reshape B. So what I can do, that I can do B dot reshape. So we have this function reshape, using which I can reshape it. So it is already 2, comma 3. The shape is 2 cross 3. So I flattened it. Now I can convert the shape as 3, comma 2 and then print B after reshape. So before reshape my B was this was my A. Before reshape my B was this, and after reshape my B became this. So one thing to note here is that the number of elements should be same. Like here I know that number of elements in my flattened B is 6. So I have to reshape in such a way that that number satisfies. Suppose if I do 3, comma 3, then it will give me an error, because cannot reshape array of size 6 into shape 3, comma 3, because 3 cross 3 means 9. So obviously we are less of certain number of elements. So 3, comma 2 means there are 6 elements. So all these elements will be filled with these elements. Okay. So it is important to note the shape while reshaping the number of elements. Yeah. Next is sorting data. Suppose we have certain data or numpy array and all those things. Then if I want to sort that data in ascending order or descending order, then I can use a function that is sort. So suppose here I am making another array np dot sort, which is the sorted array of A. axis is equal to 1. So I am sorting it horizontally. So each row will get sorted. This is 5, 4, 2, 3. So here I have printed A. Now I'll print the sorted one B. Yeah, so we can see that 5, 4 is being sorted, 4, 5, 2, 3 is already sorted, so 2, 3. So this is, each row is being converted into ascending order here in the output B. Now, if I want to know the index of these, of the sorted array basically, like this is the array that is unsorted. Now, after sorting, we know that this index of this element will become 0 because this is less than this. So this will be swapped. The 4 will come here and 5 will come here. So this 4 will have index 0 in the sorted element, in the sorted array. This 4 will have index 0. This 5 will have index 1 in the sorted array row. So if I want to know that index, that indices of the complete array, so what I can do, I can use j is equal to np dot arg sort. Now remember, we have used arg minimum, arg min, arg max to find the index of the minimum and maximum value before. Let me show you before where we did that. Yeah, you can see here, like this arg min is giving me the index value. This arg max is giving the index value of the maximum value in that element. Now again, while sorting, I want to know the index of each element after getting sorted. So here j is equal to np dot arg sort of a. So if I'll get print j, then I can see that I'm sorting here a. So yeah, we can see that this was my a, this is my b, and this is my j. So I want to get the arg sort of a. Now the index of the sorted, so here this is the sorted one, b is sorted, and c, this j is the index of the unsorted one when it gets sorted. So after sorting, this becomes like this. So we can see that 4 is having the index 1 in case of a, but in case of b, after sorting, we are having the index 0 of 4. Okay, so just let me just remove this. Yeah, so this is the np dot arg sort of a, that is j. So this is my a. Now this 4 is right now having index 1, but after sorting the index should be 0 because 4 is less than 5. So here this is giving the value of index in that value. So here 4 is having the index 0 after sorting and 5 is having the index 1 after sorting. So this is the output that provides us the index value of each element in that matrix A that will be after sorting. Okay. So these are the basic numerical operational methods in that we can use with NumPy library. Thank you.